So welcome to this talk. It's called Moving to Mobile, and I'm still trying to figure out if I should say mobile or mobile. I'll figure it out. I'll keep interchangeably using it. But it's moving to mobile workflows for Unreal Engine mobile development. And this is pretty much the agenda. I'll just give literally 3 slides of introduction, and then the meat of this talk is really going to be the technical expectations that one would have when you're creating a cross-platform mobile game. Then I'll also be talking about the Epic game ecosystem at the very end, and then pretty much end with the roadmap. So that's pretty much the agenda of today. Quick introduction about myself. I am Arvind Neelakantan. I am from India, in Chennai. I have been a full-stack game developer for the last 15 years. My job really is helping people. I go around from country to country, place to place, working with game studios and providing any kind of technical direction that they might need when they are making a game. Not necessarily just mobile games, but these days I've been mostly working on mobile. I also lead some instructor-led initiatives within Epic, providing infrastructure and whatnot. And if you'd like to connect with me, that's my LinkedIn profile. All right, with that, let's get started. Now, mobile gaming is really a force to reckon, right? Just in terms of revenue alone, in the last decade or so, or more than a decade, we're seeing like this mobile device is really growing in people's hands. And it's the form factor is now over 2/3 of the new spend since 2011. And it's also up by it's 55% of the total market of revenue that comes in games, which is up by, again, 32%. And the hardware is also getting much better, right? Today, we have about 40 million people who own a mobile device capable of running games with a mid-grade Gen 8 console specs. And in 2030, which is not far off, which is just really 5 years away, 1 billion people will have such a device. And when it comes to the visual parity between mobile and PC, it's getting quite close. Now, this was a YouTube video by this YouTuber called Dear Impact, who compared this game called Tower of Fantasy Hota, which is made with Unreal Engine. And it's a side-by-side comparison of mobile versus PC. And you can see that it's pretty close. There's not a lot of discernible differences. And I think as mobile phones gets better and better, this parity will only become better too. So mobile is very important for Unreal Engine. So as developers, as technical directors, or software engineers, what are the technical expectations that you would have when you're making a cross-platform mobile game, which is on the AA, AAA realm? And the important thing, I'm a developer myself, is I don't want to be branching when I'm going to be creating a mobile game. I want to be having the same editor, but I also want to be having to deploy to both PC, console, and mobile. So let's look at the expectations, right? First off is developer efficiency. You want to make sure that your editor workflows, your deployment ease, your CI/CD pipelines, your testing is done in scale. And also, you want to have, when you're usually working as a team, you want to make sure that you're able to collaborate seamlessly with your team. The second part that you're looking at is your optimization in terms of both memory and in terms of just performance. So you want to make sure that the assets that you're going to be creating is going to be applicable to all the platforms, but changes when you're deploying it or when you're packaging it. You want to make sure that you have enough tools, or the right kind of tools, to look at your memory allocations and deallocations. And of course, you also want to have a way to patch your games, to have a build and asset delivery pipeline all set up. And the third quadrant is visual fidelity. I think that's most important, or equally important. You want the engine to do most of the heavy lifting at this point of time, right? You just want to have a really good-looking game, and it should just perform as you would expect it to be performing. So I'll talk about how Unreal Engine helps you with that. And finally, third-party support. And this is something that's not talked about as much as I would like to, at least in the context of Unreal Engine. But things like ads, in-app purchases, notifications, and importantly, third-party library support, right? Because not all third-party SDKs have an Unreal integration to it. So you want to have an easy way of doing that integration. So this talk is really about how does Unreal Engine touch upon these 4 quadrants when you are going to be making a mobile game. So let's journey through making a UE game, a UE mobile game. And for this talk, I'll be using an example from the Fab Marketplace. This is a free sample project made by Epic Games called Cropout. It's a cross-platform game which also works on mobile, and you can see that's actually running on my mobile phone on the side. So let's begin with the first quadrant, which is developer efficiency. Now, when you want to start making a mobile game, be it iOS or Android, there is a very, very helpful quick start guide that you can start with, which kind of helps you set up your editor for iOS and Android. So once you set it up, you should be good to go with at least deploying an empty project into iOS or Android. For most part of this talk, I will be using Android as an example, but that doesn't mean that a lot of this doesn't apply to iOS also. I just want to give you a heads up. But once you set it up, you should then see in your Unreal editor that, in this case, Android is now enabled, and you're then able to package and deploy to Android platforms. Now, the cool thing within the editor itself is you're able to preview your game within the editor itself, and it'll give you a fairly close approximation of what your game will look like before you're packaging and deploying your game to the target device. And this is useful because you can then say, in this case, I'm on Android, I can just say, what is my game going to be looking on an OpenGL platform? What is my game going to be looking on a Vulkan platform? And so as an artist, or as an environment artist or a technical artist, you're able to get a good approximation of what your game is going to look like. You don't have to keep deploying it to device. But let's say you do want to deploy it to device, but you have a multitude of devices on both iOS and Android, and testing your game on every platform or every device is going to be cumbersome. And recently, with Unreal Engine 5.4, we now support the official emulator, the Android emulator supported or provided by Google or by the Android Studio. So if you have the emulator running, you can deploy directly from the editor. To set it up is actually quite straightforward. You need to make sure that you get the Android emulator at least version 35.2.7, which is the Canary version, and that's the minimum version. And once you set it up, you can then, you have to create a new file under the .android path in this case, Windows. And there is a advanced features.ini file that you'll got to create. Once you create that, you got to add 2 lines to it. And those 2 lines matter a lot. Once it opens, yes, I do want to open it. I'll open it on Visual Studio Code, and these are 2 lines. It's Vulkan, and also the directional has to be on. Now, the reason for that is the emulator only works for Vulkan right now, doesn't work on OpenGL, so you got to keep that in mind. But once you have that, you can then set up run your emulator from your Android Studio, which I'm sure you're familiar with, and that's it. And then you're able to deploy to the emulator directly from the editor. Now, the really cool thing about this is, if we use this all the time within Epic to do testing, because the emulator is a very, very close approximation to what your real device is going to look like. And that means that if you have to test across different resolutions, different kinds of OS or Android OS, you can actually spin up these emulators and test them on these emulators rather than having to buy those phones yourself, which is pretty cool. And eventually, I think the next part of, with Unreal Engine 5.6 and above, we are working on having multiple emulators open at the same time so you can deploy to all of them simultaneously. And if you're a programmer, I think this is a very important checkbox that you have within Unreal Editor. If you're testing your game out on the device, you don't want to keep packaging the assets that you're going to be using and cook them and deploy them to your device and install the APK every time you're just making a code change. So now we have this checkbox in project settings where you can just say don't bundle libraries into the APK file. And if you set that up as true, either in the default engine.ini file, or you can go to the project settings and turn it and just have the checkbox turned on, That means that it'll skip that entire Gradle and avoids reinstalling that APK, and it'll only push that code changes that you're going to be doing. So your developer efficiency is a lot faster. Now I can hear some of the artists in the room, which I'm sure there's quite a few, which is like, what about me? Like, how do I improve my efficiency? Well, that's why we now have Zen streaming for mobile, which is an amazing feature. I just love this. The way this works is, I know this is a very complex chart, but all you really need to look at is that at the bottom part, you can see that gray box. That's where the assets that has already been readied for you for the editor deployment lives. That's your cooked output data at the bottom. And when you have Zen streaming turned on, rather than doing the usual method that you see on the top, where you cook and then you're running UAT and then it's building, cooking and running, and then it's deploying onto the device, it's going to skip all of that top part, and it's directly going to be streaming the existing cooked assets from that's already ready for you in the editor into your mobile device. That means a game like Project Titan, which is again a free sample project that's available on the Fab marketplace. I was able to deploy that game in about 30 seconds. It's a huge game. It's like an open world game in 30 seconds, as opposed to me packaging that APK, which usually takes about 25 to 30 minutes, depending on the configuration of your PC. So this is amazing. So this is how it works, right? So you just plug in your device, enable Zen streaming, and it just deploys to the device. And you can see when it's deploying to the device, as environment artist, technical artist, or any artists, you're able to just see what your asset is going to be looking like on the mobile device directly. And you can see there's a little notification on the top which just says that the assets are streaming in, as opposed to them being cooked and packaged to your mobile application. Turning it on is super easy. Just go to your project settings, ensure that you have Zen streaming or Zen server checked. You got to add a couple of lines in your default engine.ini, which says limit your process lifetime to false, or allow the remote network service to be true. There is a pretty good documentation, just very good documentation, in fact, on that QR code. You can scan that and kind of set it up yourself. This is an amazing improvement to your developer efficiency and saves a lot of time. So then, when it comes to developer efficiency, when you're working on your game, you have deployed your game, and then this happens. How many of you have seen this? You open your game, it crashes. Huh? No one's seen it. Damn, that's awesome. You're all like amazing developers. Yeah. You open your game again, it crashes, right? This is, as an Android developer myself, usually my instinct is like, hey, let me go to Logcat. I'm going to see what's causing the crash. And that could be, you're just reading through a lot of text. But here is another way that you could also kind of debug these problems. We now support the Android game development extension for Visual Studio, which allows you to debug your game and even set breakpoints right inside your C++ code in Visual Studio directly. And this is how it works. So I have the game, I turn it on, I plug it in, and then I set up or rather I start that process from the Visual Studio using the extension. And now I'm opening the app on my mobile device. It should kind of figure out where the crash is happening in just a bit of time. Let's see what's causing the crash. There, it crashed. And on a class called Crash Actor. I don't know who created that. Someone did. But this is useful because you can then also set breakpoints inside your game and debug it as you would typically expect when you are when you're writing code, which is pretty nice. And the last part of the developer efficiency I want to talk about is Horde. Now, Horde is a whole set of tools, a lot of tools that exist that let you do, that helps you when you're working as a team. It does a lot of things like, build execution. It allows you to have like CI/CD pipelines. But the very interesting aspect for me for Horde, or when it comes to Horde, is the last part where it says mobile device management. And that's amazing because in addition to your typical CI/CD pipelines and build execution and other things like test automation that you have in Horde, what the mobile device management allows you to do is you can, through build graphs, set a period where you can just say, like, my code of this particular version has to be deployed to a multitude of iOS or Android devices. This can be both virtual devices and also physical devices. So as testers, you can check out those devices, and that means that the next time there's going to be a build, that device will not have the new build that you want to be testing it in. And then the QA testers can then give feedback on that particular version. And so it's a very nice way of scaling your testing platform itself. So I love this for that. I do want to add a caveat that if you're going to be using Horde, it only works with Unreal Engine 5.4 or above, and you will need to be compiling source code for it. And finally, on the developer efficiency part, we are continuously improving developer efficiencies. It's a never-ending process, really. But future work includes, like, async loading into the editor and PIE. You must have noticed that there was a lot of default engine.ini file changes and go and check this box and all of those things that I was doing. So we're making the discoverability of mobile-specific features a lot more apparent. There's going to be a refactor to the content browser and details panel too. We're also adding a lot of project samples specifically for mobile so that you can kind of dissect that game to see what's up with that or how did we make that game and so on. And also just general better default settings for mobile platforms. So let's get on to the second quadrant, which is mobile memory and optimization. Now, in my opinion, memory is probably the biggest issue that is faced by mobile developers, because compared to other platforms, mobile has a lot of additional challenges. So for example, unlike PC, we have no virtual memory, or rather, we have virtual memory, but no swap file. Or swap file on the flash storage, which means if we have to ask for more memory, we will not get more memory. We'll end up with the out of memory exception and our game will crash. And similarly, we can have data which can be stored directly in memory, which we call memory map. But there is no swap to large swap file on the storage, which means our game will once again crash. And on Android, we do have this really cool feature called ZRAM or ZRAM, which allows you to compress your memory that's being used by apps in the foreground. But if you still run out of memory, because there's like a background application or Frogo or another application that's asking for more RAM, you will again crash. And similarly, on consoles, unlike consoles, there's no fixed amount of memory available because the amount of memory varies by device, by the OS versions. And on Android, also, your background processes can also take up memory and might cause problems. So why am I telling all of these things? This is because there's so much going on memory that memory analysis tools on mobile become very, very important. So which is why we have Memory Insights, which is a brand new tool, which has been available since 5.4 for Android and 5.5 for iOS. Now, this is a very cool tool because in Unreal Engine, we are able to tag all the memory allocations using an LLM tag. And so let's say you're loading a brand new level from a previous level. So in the previous level, all the allocations that has been made has to be deallocated when you're loading the new level. But if the deallocations don't happen, this tool will then highlight and flash all of those memories that has not been deallocated and or meant to be deallocated. So this really helped us fix a lot of leaks in our own internal games. So definitely check it out. I wrote a nice Epic Developer Community article, which you can scan from over there to help you set up these memory insights, and that should help you with your memory profiling. So let's also address the big elephant in the room, which is build size optimizations. Now, within the editor, we have been making a lot of changes internally to make sure that the overall APK or the IPA file doesn't really bloat. It becomes as small as possible. There's a lot of compression techniques like the OODL compression. We have been doing a work on GNU hash and startup time, APS reallocation table compression, and so on. But these are like hidden changes. But as developers, we also have a lot of control over how we can manage to reduce the size of our build. And that's through a number of things like mesh optimization, texture optimization. and so on. Like, for example, in crop out, I was able to reduce the build size from 218 megabytes all the way down to 120 megabytes. And you can even go further if you want, if you're going to be using some kind of patching mechanisms like using Google Pad or whatever. And I'll talk about how you can do this. And these are especially useful when you're going to be making a cross-platform game. So let's begin with mesh optimization, right? When you open up any kind of mesh, let's say you have a nanite mesh. Nanite, at least at the moment, doesn't work on mobile. So it'll go back to a fallback mesh. But when you have the fallback mesh, it'll have a lot of polygons in it, and you don't want that many polys on your mobile device. So you have an override on your mesh settings where you can say, if I'm going to be deploying and packaging this application for mobile, then use a LOD3 instead and ignore LOD0, LOD1, and LOD2, which means your build size goes down and your performance also goes up, and your artists don't have to maintain 5 different kind of meshes, which is pretty nice. And another thing is, when you make this change on one mesh, you can also copy the same setting. And if you have thousands of meshes, you can then copy that setting and paste it simultaneously to all the other meshes, so that you have to do it for every single mesh that you have. Then on the texture optimization front, let's say this texture is a 2K texture. And maybe 2K texture is cool for a mobile or for a PC console device, but I don't care about it for I'd rather have a 1K texture for a mobile device. So it's important to have texture groups set up for all your textures. When you have a texture group selected, what happens is you can go to your device profiles. So if you go under device profiles, platforms, device profiles, and the device profile shows you a list of all the devices supported by Unreal Engine. And I'm just going to scroll down to where it says Android. Now you'll notice that even under Android, there's other Android devices supported. So if you make a change to the parent Android, all of that changes will propagate down to the other Android devices also. But here I can open up the Android device profile. And in there, if I scroll down, you'll notice that there is something called the texture group, texture LOD group. And in there, I can say, if my texture LOD group is world for any textures that's marked, even just cap it to a 1K texture. And I can do it for all other kind of texture groups too. Like, I can just say if it's going to be a foliage kind of a texture on a PC console, make it 1K, 2K, but on mobile, make it 512. And I can do that for texture groups. So in one sweep, I can both reduce the build size because my texture size goes down, and I can also reduce or rather improve my performance. And while we are in the device profiles, there's also the console variables, which you can set by device or per device. So in here, I can just say like, hey, you know what? I don't want wind, or I don't care about a particular physics component. For example, in crop out, there's like little guys who are walking on the ground, and they have a rigid body physics that kind of blobs their hat up and down. I don't care about that for on mobile because it's such a tiny guy. So I can turn it off on mobile, but keep it on when I'm playing on PC and console. Next up is shaders. Now, when you're working with shaders, one of the first things you want to look at is instruction count. And by default, you won't see Android or iOS, but so you have to go under settings and then see what's the instruction count going to be on for Android and for mobile devices. And when you have that instruction count set up, now similar to your textures or meshes, you don't want to maintain 2 different shaders, right? And so we have a node here which has been around since I think 4.25 and before that, which is called feature level switch. Now, what feature level switch allows you to do is in the same material editor, you're able to say, like, depending on where that shader is going to be deployed to, you can just say, hey, on a PC console, have a more complex shader, probably, good looking one. On a mobile, make it more efficient and maybe have a backup. And that's kind of what this node does. So you can see at the bottom part, I'm actually just using a texture, whereas on the top, I'm doing a lot more complex shader instructions. So that's on shaders. And then about chunking and pack files, which also help you reduce your build size. Now, enabling chunking is is quite easy. Chunking is a very common thing that you do on mobile games, right? Like you will have your APK file or IPA file, and you would want to then patch your assets from the server, and that's what chunking helps you do. So make sure that you go under project settings and just make sure that you have generate chunks turned on. I've done this mistake so many times where I'm like trying to create a chunk and I forgot that I have to enable that. But once you enable that, you have to go under any of your folders that has assets in it. So in this case, I have an environment folder, and I'm just going to be creating what is called a data asset, particularly or specifically called a primary data asset label. I create that data asset. I fill in some parts of it where I'm going to make sure like what's the priority of it, what's going to be the chunk ID. It has to be greater than 0, and have some cook rules on it. And once I do that, I have to then package my game, and this will then separate out all the assets into its own separate chunk. So in this case, my environment will be its own chunk. I also had another chunk maybe for my vehicles. I can have that as my own chunk. But this doesn't end that process, because like let's say I open up my OBB file if I'm on Android, and you'll notice that even though I created those 2 chunks, and it's just a zip file, right? So I'm just going to open it up, and you'll notice that pack files actually just stay in there, like it's part of the OBB file. So what's the big deal? Like that chunking really didn't help at all. So there's an additional step that you need to do, which is you got to explicitly exclude the pack files that you don't want to be part of the original build. And that's done in the default engine.ini file. So under Android runtime settings, you need to add a line which just says like, hey, exclude any, you can add an OBB filter. So you can just say like, hey, anything that contains this signature, which is in my case a pack chunk 1 star, exclude that to be part of my build, so that doesn't get packaged. Don't worry that, so next time you package, that'll go away, but those additional chunks will lie under your staged folder. So you can see that's where they live. But except for pack chunk 0, which never gets, that's your base game, all of the other chunks will get excluded. So then you can then push those chunks from your server. Now, if you want to know how to push those chunks from the server, there is again a really nice article on how to host those files and push it to your mobile device from your CDN server or whatever. And if you are a fan of Google Pad, that's also supported within Unreal Engine. So if you can just turn it on from the plugins, and there's a few settings that you need to work on, and you should have Google Pad, the asset delivery system from Google, also ready for it. Now, this is a very large topic, right? So again, as I usually do, I also wrote a very long article on the Epic Developer Community Portal addressing just build size optimization. Like there's a lot of things that you can do. I went like mostly surface level at this talk due to time constraints, but you can check it out, and there's a lot more tips that you can use in order to reduce your build size. Now let's look at the third quadrant, which is visual fidelity, rendering, and performance. Now this is what Unreal Engine is probably most famous for. Here is a game. It's called Netmarble's King Arthur Legends Rise. This was captured directly from the mobile device. It looks amazing. And so out of the box visual quality that you can get out of Unreal Engine is almost a given. It's really nice. And it's not just this one, right? Like, so these are other screenshots from the same game. This is like an environment. This is like a nice little arena. And this is another game, which is Kuro Games' Wuthering Waves, which has been making a lot of waves in the mobile community. Thank you, one guy. And then there's other games too, right? Like, there's Tower of Fantasy Hota. There is, which I just showed you earlier. There's the Oregon Trail, Ni no Kuni. Fortnite, of course, works on mobile. And I'm from India, so from my neck of the woods, there's Raji, which is a beautiful looking mobile game. Also cross-platform. There's Final Fantasy. There's Blue Protocol. There's a ton of games that's of AA, AAA quality that works really well on mobile. And in fact, and this has been even like older versions of Unreal Engine, right? But since 5.4 and 5.5, we've been adding a lot of improvements specifically for mobile also, so that your performance is awesome, but your visual fidelity is also amazing. So things like GPU scene, ISM GPU culling, loading, landscape GPU culling, forward light optimization, runtime PSO pre-caching. There's a lot of words. So let me explain what they are one at a time. So what's GPU scene? So typically, when you have GPU stores a lot of your mesh information, including things like your rotation, transformation, scaling, and all of that. Now, what GPU scene enables you to do is it will batch all of this information over to the CPU so that the draw calls that you have on your CPU is reduced. Now, this has been the case on PC and console for a very long time. So for PC console developers, you're like, yeah, so what's the big deal? But it hasn't been available for mobile applications for a long time until now. So we were able to find a few workarounds. So now GPU scene is enabled by default on mobile devices. And what this allows you to do is we can do things like instance static mesh per instance GPU culling, which means it's able to understand what are the parts of the mesh that the user or the player is going to be seeing and able to cull out based on just that instance static mesh. Automatically, this is also turned on by default, which is the instance static mesh GPU loading. So depending on how far away the mesh is from your camera, it's able to do loading for you. Which is also amazing on a mobile device. We also have landscape GPU culling. So if you're creating open worlds on a mobile device, that's also taken care for you now. And this only works on Lot 0 for now, because other Lot 0 of the landscape for now. But it's able to essentially just split the landscape into smaller chunks and load the landscape based on what you're seeing. Doesn't work if you have landscape nanite turned on, or doesn't work if you have lumen turned on, but it's very, very fast and very, very efficient. So in fact, a game like Project Titan, I was able to just put it on a mobile device and it just works fine. And we also have runtime PSO pre-caching turned on by default. For folks who don't know what that is, I'm sure you would have seen this behavior in games where I'm turning around and it just goes boop, 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 boop. And then it's fine. Then you turn around again, and the second time you turn around, it works fine. Now, there could be a multitude of reasons for this, but we were able to figure out for this particular example, it was in fact the PSO compilation hitch, or otherwise called the shader compilation hitch. Now, this is happening because whenever the engine renders some object with shaders for the first time, it needs to create and compile those shaders for you. So when it's compiling those shaders, you see that glitch happening. Now, earlier, we still do have this solution, which is called PSO gathering. And this is a solution because what you have to do for PSO gathering is you have to run around in the entire game, gather before you package it, right? You run around the entire game, gather all the shaders that's there inside your game. It'll compile it while you're running through the game. And then you're able to store that and then package it as part of your as part of your game. And this is a problem in two fronts. One, if you have a very large game, it's impossible to go to every nook and cranny of your game and figure out what those shaders are. And second, it also adds to your loading time of your game because it's going to load all of those shaders up front. So to have a middle ground, we now have PSO pre-caching, which is a brand new feature. Now, this is a system where when a game loads a level, for each loaded static skeletal mesh, landscape, particle, and any other component that we are going to be looking at, it's going to collect all the possible PSO that those components can have. And so the idea is by the time we need to render an object, the shader would have already compiled. Or at the very least, it will have a backup shader that will show before, rather than hitching the frame itself. There is a fallback strategy where you can, like I said, we can note that over there. There's a fallback strategy if the PSO is not ready. But I think with a combination of PSO gathering in some cases and with PSO pre-caching already enabled, we can reduce these hitches by quite a bit, or in fact, ideally just make it disappear. And finally, on the rendering part, this is a question I get asked all the time, which is nanite and lumen on mobile. The answer is we do have desktop rendering on or renderer on mobile, but it's currently experimental. Do not go to production with it yet. But on high-end mobile devices with Vulkan RHI, we do allow you can have Lumen and Nanite to run on these platforms. All right, the last quadrant, which is the third-party support, which usually involves ads, in-app purchases, and notifications. Now, this is probably the shorter part of my talk because this is a lot of less evangelized part of Unreal Engine, which is ads are natively supported. So if you're using AdMob, you just have a node on Blueprints called Show Ad Banner. You see ad banners, and you hide ad banner, it just goes away. And so similarly, we have interstitials and so on. All of that nodes just exist by default, so you don't need to do much. Similarly, you also have in-app purchases available as a node. So if you have, get in-app purchases or make an in-app purchase node, start an in-app purchase node, you just have to fill up a data asset where you're going to kind of define what those assets that you're going to be purchasing are along with their key, and you just call them through this node and it just works. And similarly, same thing for notifications. If you're looking at local notifications, you have a schedule local notification from now, a node, and you just schedule it and it'll just work. But what about SDKs or third-party SDKs that don't have Unreal Engine support? I would kind of ask you to check out what's called API-gear.io. Now, this is an open source platform or open source project that's maintained by Epic Games. And what this allows you to do is you're able to describe any API from, say, I don't know, Netflix or any other kind of gaming SDK that you're going to be integrating. Describe that API surface, and API Gear will generate the UE plugins for you based on your definition of that API. So it can be Blueprints or C++. And then once it generates that code, you're then able to just fill in your business logic, as in what would you want to do when you consume that API? And then you're done. That's it. It's super easy to do. I would recommend that you check it out. It's on GitHub. If you go to apigear.io, you should be able to check it out. So that's pretty much all the 4 quadrants, right? Whether you're looking at developer efficiency, where things like editor workflows, deployment ease for both programmers and artists, CI/CD pipelines through Horde, and testing through Horde, and also team collaboration through Horde, you are set on that. The mobile memory and optimization for making sure that you're able to identify memory leaks through mobile memory insights, and also that list of things that I was talking about to reduce your build size. And also the ability for you to just push assets from the server through Google Pad or through chunking mechanism. And of course, visual fidelity is just high, right? You have GPU scene, and you have the static mesh instant static mesh culling, the loading mechanism, and so on, and PSO pre-caching, which are all newer features, but also just out of the box, even with older versions of Unreal Engine, you're able to get pretty amazing visual quality. And of course, third-party support, which is in-app purchases, ads, notifications, third-party libraries, integration, and whatnot. And it's not just that, right? It's not just the editor, but at Unreal Engine, or Epic Games, you also have a full ecosystem of tools. So you have the editor, which is a tool for you to make the game. But if you're looking at content, you can get it from Fab. Cropout is available on Fab, for example. And if you're going to be making, say, a multiplayer game, you could use the Epic Online services. And of course, if you want to distribute that game, you could put it on the Epic Game Store. And if you make Fortnite for UEFN games, and then we have a very vibrant community like the ones over here, where if you want to ask questions, you can check it. You can ask questions to the community on the Epic Developer Community Portal, or if you're an artist, you can check it out on the ArtStation. Talking about Epic Game Store, we are also now available on mobile. So if you can get the Epic Game Store for iOS and Android, iOS for Europe alone, Android worldwide. You can scan that QR code to download that Epic Game Store. I also want to give a shout out for Epic for Indies, which is a program where we also have, in fact, a separate mobile section for indies where you can sign up, and you will be able to get weekly syncs with folks within Epic, and the community itself is on Discord, so you can also talk to all the other indies who are going to be making games using Unreal Engine, and also on Unreal Engine for mobile. And it's a really cool place to just exchange ideas and also just make a game with support from Epic. And this is the roadmap that we have. There's a lot of things that we're working on, we're bettering the entire Android setup experience. On-device iteration is continuously being worked on. And of course, we are going to be continuously working to make sure that Lumen and Nanite is available on as many devices as possible. Self-promotion. I did also give a couple of talks at UEFest Prague, where I go into a lot of detail about how to do things like, build size reduction, how to do performance optimization, all of which I was kind of hitting like topics at this point of time, but these talks go in a little further. And then another talk at UEFest Seattle, where I also go even further when you're going to be making open worlds using Unreal Engine. So that's about it. I think I'm right on time. So that's me. That's Arvind. I'm Arvind Neelakantan. If you want to connect to me on LinkedIn, that's my handle. And maybe I can take a selfie now and I can post it on my LinkedIn handle and you can all like it or whatever. But that's my talk. And if you have any questions, please feel free to ask them over at the mic and I'll be happy to answer them. But before that, I want to thank you.